Okay, so the test on sequences and series is tomorrow, and here's a few last review problems for you. So I've got one on the screen here. It's the first one in the notes. I'd appreciate it if you would give these a shot. Why don't you get through the first two here, and then I'll have the sub resume again after we've paused to give you some time to write out these formulas. Teacher was nice that made this and included the u sub n and the u sub n minus 1, so that should save you some time. So I'll have the teacher pause for a minute and have you give that a try. Okay, we're back. Let's see how you did. To start with, u sub 1 is just the first term, so that 62 goes right there. And then you'll always say u sub n and u sub n minus 1. Those will not be given to you. You have to write them out yourself. And then if it's multiplied by the same thing each time, you'd put that in parentheses. I hope you noticed what this one was doing. Looks like it's dropping by 7 each time. Okay, so then I'm going to put minus 7 with no parentheses, because otherwise it would mean multiply by negative 7. Okay, the next one here. Oh, wait, and a domain. Did I catch you? N greater than or equal to 2. It's going to be so easy to forget that domain. And I'm sure some of you probably just did. Remember that saying that these formulas only work to predict the second term or later. You can't figure out the first term by just knowing that you subtract 7 each time. You got to know where to start. All right, so here we've got 4 going to 6, going to 9, going to 13.5. And anytime they have a decimal like that, it makes me suspicious that we're multiplying by something. Okay, so I think we're multiplying by 2. No, not 2, because that would bring this one to 8. So must be multiplying by, well, here's how I do it. I divide these two, and I go 6 divided by 4 is 1.5. 9 divided by 6 is 1.5. That's called the common ratio. And so it's multiplying by 1.5. And what was the first term? It was a 4. So again, you get that by going 6 divided by 4 or 9 divided by 6. And they'd be the same. And that's why it's called a common ratio. All right. N greater than or equal to 2, because there was one bigger than that. All right. These look like they're just a repeat of the previous ones, so we're going to skip over those. I think we've done enough practice on that kind. Let's talk about arithmetic versus geometric. The reason you mainly need to know these is there's that list of formulas, and if you don't know whether your particular sequence is arithmetic or geometric, you won't know the right formula to pick. So if arithmetic is the kind where you add or subtract, and geometric is the kind where you multiply. And I can't really say divide, because technically you can't divide in these, but you can multiply by either something bigger than 1 or something less than 1. And when you multiply by things that are less than 1, you're doing geometric and it's going to shrink. And the ones that's especially interesting on those is if you go like 8 and you multiply by 1/2 and you get 4 and you multiply by 1/2 and you get 2, etc. That kind where you're multiplying by a number less than 1, that's the kind where you can add them up to infinity. So that's the only kind where you can do the sum to infinity. So all those infinite little parts, and it'll come out to a nice clean number at the end. All right, so arithmetic sequences, this is the official definition. This is the kind where, for instance, we're adding 4 each time, okay? Geometric is the kind where you're multiplying by a constant, and you can multiply by something less than 1, and that'd be like one of these. And that's the kind where we can add up this series to infinity. Something that's going up like this, you can't add it up, because it just keeps going up, up, up. It's also going to go to infinity. But this kind, you can find the infinite sum of them. All right. There was always some confusion about this whenever we teach this, because it'd be so much nicer if we could just say you always start with u sub 1. And I can say you usually do start with u sub 1. But what would be a case when you wouldn't? So when you would start with u sub 1 would be, for instance, if you want to know the third term. because then u sub 1 is your first term. Let's say we're going to like add 5 each time. We start with 5, we add 5 is 10, we add another 5 is 15. Then u sub 1 is the logical thing to start with, because if you want the third term, then it'll be called u sub 3. If we had started with u sub 0 in that kind of a problem, it'd mess you up, because you'd think, oh, I want the third term. But the third term is actually called u sub 2. Okay, so this is definitely weirder. So why would you ever use u sub 0? If you're doing a real-world problem where something's going to happen between the start of the problem and at 1, then you need to use this. So for instance, let's say that I start with 25 bacteria, and after 1 minute, it's supposed to have doubled. Well, then I want this to be u sub 1, because at 1 minute, I have 50, not 25. Okay, so it's pretty much only in real-world questions where something's happening before the first, after, like it's after 1 year or something, is where u sub 1 would be. All right, so let's look at a couple. Lab tech notes that a group of bacteria that start at 100 is doubling every hour. All right, write a formula to represent this. So first of all, let's answer these. I'll pause for a minute. Why don't you write this out? And we'll come back after the teacher feels like you've got it done. Okay, so if it's doubling, that means we're timesing by 2, right? And so this formula would be u sub, is it 0 or 1? Well, I would have accepted if you wrote this as u sub 0, but I would have also accepted it if you'd have said u sub 1. So let's talk about that. U sub 0 equals 100. U sub n equals u sub n minus 1. This is writing out the formula. I know some of you probably thought you're supposed to look it up on a sheet. Nope. This is what is called to write a formula, not use a formula. All right, so u sub 0 is 100. That's the starting. And then I got my boilerplate stuff that I always have. U sub n equals u sub n minus 1. And then I'm timesing by something. I'm timesing by 2. That's how you're going to get it to double. All right. So it's multiplying by something, so that makes it geometric. And geometric have a common ratio. When you divide them, you can see what you have. So, all right. So now, let me just show you what would have been different if you'd have said u sub 1 equals 100. U sub n equals u sub n minus 1 times 2. Looks pretty same, isn't it? If you did have a domain, which you should, n greater than or equal to 1 for this one, because it's 1 bigger than that, and n greater than or equal to 2 for this one, because remember this little domain thing is always 1 bigger than the n you started with. So another one of those important things, that n is the subscript. You're going to see it in those equations, so you got to know what n is. And this is the r, the rate at which it's changing. N is the subscript. So if they wanted to use sub 20, then 20 is your n. Okay. All right. Now, which would I have picked for this problem? I would have picked the u sub 1 for this problem, and just know that what I'm going to be finding is if I do u sub 2, that's how many I had after the first double. Okay, so u sub 2 kind of makes sense to me to be after the first double. Okay, all right, back to this. The number of students enrolled in a school is decreasing by 12 each year. Oh, so I know it's going to be a minus 12 in my formula. And it starts with 634. All right, so if I go u sub 1 is 634, u sub n equals u sub n minus 1, and then I'm going to go, let's see here, decreasing by 12. Oh, this would have been a classic mistake. That would mean multiply by negative 12, so I got to get these parentheses out of here. There we go. Okay, and just understand what you have here. 634 is the first one, and we're going to decrease 12 each time. So like the next term's going to be 600 and subtract 12 from this, 22. And this is u sub 1 and this is u sub 2. You'd have to just be careful. And if you were going to answer a question about this, that maybe, depending on the type of question, you might have used u sub 0 here. And then this would be u sub 0 and u sub 1. After 1 year, how many people were there? It would either be u sub 1 or u sub 2, depending on what you started with. Okay, your formulas are mostly meant to be used with u sub 1s, so you got to be careful with that. All right, so if you're really torn, default to using u sub 1. It's a safer bet. All right, so suppose you invest $500 in the stock market. And after 1 year, your broker reports the money has decreased by 8%. To me, that feels like your $500. After year 1, they want me to do after year 1. Well, it's not $500. Okay, I started and then it decreased by 8%. So I could use a calculator to do this. And what I'd do is I'd go 500 and I'd multiply by 1 minus 0.08. Yes, that's the same as 0.92. All right. I'll pause for a second while I find that. Okay, so that's 460 after the first year. Do you see how this would be a good one to start with? U sub 0 was 500. Because after 1 year, this will be u sub 1. Gives you 460. And then, but I would have grabbed a calculator for this one anyway. And I just keep on multiplying by 0.92 over and over again. Keep getting those answers. That was a common ratio because we're multiplying by something. And since this one's going down, we would subtract from 1 each time, like I did right there. So, all right. There's a lot of problems in here, and frankly, I feel like you'll be bored out of your mind if I keep on doing those problems over and over again. So let's move on. Yep, more of the same. Let's get to the sums and the partial sums. So these are the big formulas. They will be given to you just like this on the test. Okay, so we have a formula sheet built into the test with these formulas. Okay, and notice that they all use u sub 1. So if you're doing a sequence or a series question, then you should use u sub 1 as your starting term because it's built into all the formulas as u sub 1. That's pretty simple. And u sub 1 is the first term. All right, so if it's a series where you're adding everything up, you need these formulas, then make sure you use u sub 1. All right, so let's talk over some of the key letters here. N is the subscript, which is like which term you want. So if I said u sub 20, that would mean the 20th term. Okay, this is the first term. This one here, first term is that. N is the same exact N from this. It's which term you're on. Minus 1 is pretty self-explanatory, and D is the common difference. And some people thought that if it was like subtracting, you would subtract the difference right there. No, this is a times the difference. Okay, so whatever the difference is, if it's going down 3, you'd multiply by -3. If the difference is it's adding 2 each time, then you multiply by 2 right there. But it's multiply either way. All right. So again, first term, N is the subscript number. So if you're figuring out, N sub 20, then it would be that same as that number. Okay. What else do we have to know? Ooh, R. R is the common ratio. So if you had one where it was going 20 and then cutting in half to 10 and cutting in half to 5, okay, we can figure out the fifth term. Notice this is not a sum. It doesn't have an S. These are the ones for sum. Okay, so this would be like to figure out the fifth term for ones that multiply, geometric. So this one's the one that multiplies. And if I wanted to figure out the like fifth term, I'd do u sub 5 equals, and then I would use this formula. We'll practice those in a minute on the other page. Actually, let's practice it now. All right, everybody, you guys should try this one right now. So I'm saying we're starting with 20, and it goes down to 10, it goes down to 5, and I want the fifth term. Okay, use this formula right here. Let's pause the video for a second, give it a shot. Okay, you're back. So u sub 5 would be this formula now. U sub 1, which is 20, because they asked for u sub 1. And then r to the end. R is the rate. The rate here is it's cutting down by a half each time. If you want to know, you can always divide this divided by that. 10 divided by 20 is 1/2. 1/2, yes, you can use 0.5, and you'll have a calculator for the test, at least if you bring one. I always have a couple that I can lend out, but please bring your own. And then it's n minus 1. Well, what's n again? N is that subscript number, and so that's this number. And so then you go 5 to the power of, sorry, but put it up high, to the power of 5 minus 1. I just did this part right here. Okay, now I'm at 20 times 0.5 to the 4th. Just a second for my calculator. And I got 1.25. I hope that matches up with what you got for the fifth term. And I think I could have done this one in my head, because I'm just cutting things in half. Half of $2.50 is $1.25. 1.25. There we go. First, second, third, fourth, fifth term. All right. This is the kind where you would add up a geometric sequence, probably the most complicated one. So like this one, except you would actually be adding all 5 of those terms. Now that we have them all, it'd be easier to just go 20 plus 10 plus 5 plus 2.5 plus 1.25. But let me just show you how you would have done it. You would have taken this formula, and you said u sub 1, which is 20, times the rate, which was 0.5, to the n, which was, we wanted 5 terms to be added up, minus 1, all divided by the rate, which again is 0.5, minus 1. That's this formula right here in action. All right. And last, I'd like to try one of these where we're adding up an infinite geometric series. All right, this only works when it's shrinking. So let's use the same example one, 20, 10, 5, 2.5, etc. Okay, and apply this formula. The teacher pause for a second, give that a shot. All right, so you use this formula, s sub infinity, adding it up to infinity, u sub 1 is 20, over 1 minus r. Now I've always done, not always, but often done this where I'm cutting it in half. You know, it doesn't always have to be cutting it in half. Whatever the rate is, which you can always get by taking this divided by this, whatever that rate is, that goes here. Okay, so in this case, it is 10 divided by 20, which is 0.5. Okay, so now I have 20 over 1 minus 0.5, and that is 20 over 0.5. And dividing by a half, which is what that really is like timesing by 2. 20 times 2 over 1, and I get 40. That's what that would add up to, that infinite series. And it's so strange that an infinite number of things can add up to something finite. But it's true. Otherwise, I gave you that example of getting out the door in the classroom. You have to go halfway to the door, which might be like 10 feet. And then you have to go half of the remaining 10 feet to get out the door, and that might be like 5 feet. And if you're doing sum of an infinite geometric series, some people will say, well, then theoretically, you can't make it out the door. But you can because of math. And this formula can be used to prove it. All right. So I think it would be great for you to practice these. We did some already. And just know where to look. You know, that formula, it's clearly a sum of the first 9 terms. This is a term. It's the 27th term. That was for arithmetic. Here's geometric and a sum and the first 11 terms. All right. And I think for last thing in practice in class today, I'd like you to do these 3. And then I'm going to come back and grade these for you, and we'll resume the video for that one last time. And then you have a Schoology quiz, which you need to do. You start it in class, and then you finish it overnight, which is your last review for the test. Pausing while you try these 3. Okay, so you're back. Let's see how you did. So if we're going to do this one, it's the 9th term. They wanted to find, oh no, wait, sorry, the sum of the first 9 terms of this. All right, so I identified it's arithmetic. It says so right here. Otherwise, I could have just known that they're subtracting 2 each time, so it must be arithmetic. And I look on the sheet for arithmetic and series, and that's this formula. S sub n equals n over 2, and then 2 times u sub 1 plus n minus 1 times d. Okay, now I'm just going to put the numbers in. So this is the 9th term. So it's 9 over 2. 2 times the first term, which is 22. And then n is 9 again. And the common difference is negative 2. But I'm not subtracting 2 there. I'm multiplying by it. 9 over 2 is 4.5. And then 2 times 22 is 44. Plus 9 minus 1 is 8 times negative 2. So I'm going to need the calculator here. And I hope you guys got 560, because that's what I got when I put that in the calculator. All right, next up, the 27th term. Well, that's this formula. U sub n equals u sub 1 plus n minus 1 times d. Then I'm going to take and put in all the things I know. I know this is 27. I know u sub 1 is a starting number, so that's 22. And then n minus 1. N is, again, our same number here, 27. Times d, the common difference, which was negative 2. So a little easier formula this time. 22 plus 27 minus 1 is 26 times negative 2. And let's see, 22 plus negative 52. I think that's negative 30. I am sick, but I'm pretty sure that's right. All right. So let's get to the geometric series here. So for the s sub 6 on a geometric, how do we know it's geometric? That divided by that times 5 is, it's 5. So when you go 3 times 5, you get 15. Times 5, you get 75. So this one's a times 5. All right, why is that important? Because that's your R. We'll put that in the right formula when we get it. So this is a geo, so if you look on the sheet, you're looking for a geo S sub n. And we do have to know whether or not it's a infinite geo or not. And this is, well, you could do it infinitely, but you can't add this kind up because it's going up. So this is, you can't even do that. So it has to be this formula. S sub n, because it can't be the infinity formula because our numbers are going up. U sub 1, r to the n minus 1, all over r minus 1. Putting in my numbers. U sub 1's 3, r 5 to the n, that's given right there, 6, all over, r again was 6. Calculator pause. And that one came out to 9374.4. And that is the sum of 6 terms of this. All right. The reason it gets so big is when you're multiplying by 5 over and over and over again, your number's going to get really big really fast. All right, this one's u sub 11. That's saying I want the 11th term in this geometric series. And there's a term finder for that. Pausing for a second. Okay, looked up my formula, and it is u sub n equals u sub 1 times r to the n minus 1. Then I'm going to go and fill in what we know. Our u sub n is 11, and the n's 11 again right here. And our r, our rate, is times 5. And our u sub 1, our starting number, was 3. So I need to calc for that one for sure. 5 to the 11 minus 1 is 5 to the 10th is pretty big. And on this one, I came up with 292,968,75. Put in the commas like a normal person. 29,296,875. All right, and if you've got this infinite geometric series, they're kind of hinting it's infinite, but you know what? If you want to keep going with a series, you can always keep going. So they're kind of all infinite series, but this is the kind, since it's shrinking, that you can actually use that infinite sequence on. Okay, so one thing at a time. First, we got to figure out u sub 11 for geometric, and that's going to be u sub n equals u sub 1 times r to the n minus 1. I'm going to put in my numbers. U sub n is 11, and u sub 1 is 36, starting number, times r, which is, well, if I take this divided by this, 12 divided by 36, that's 1/3. 4 divided by 12, 1/3. Okay, so that's 1/3. It's better to use that than a decimal, because if you typed in 0.3, that's not very accurate. 1/3 is actually 0.33333, so you probably should use 1/3 on the calculator. Then n, which is 11, again, minus 1. Calculator time. Okay, so the 11th term in this sequence, it's getting really small. You might have seen this on your calculator, 6.09663, etc. And then an e negative 4. If you've never seen that before, that means you take the decimal and you move it back 4 places. So decimal and then 3 zeros, and then the rest of this number. And the decimal's not there anymore, it's over here. So it's a really small number. And last but not least, the infinite sum of these, like 36 plus 12 plus 4 plus, etc. Well, obviously it's more than 36, right? We would use this formula. S sub infinity equals u sub 1 over 1 minus r. U sub 1 starting term, 36. 1 minus r, the rate, 12 divided by 36, 1/3. So it's really 36 divided by 1 minus 1/3. I can do that in my head, it's 2/3. And then if you know anything about fractions over fractions, you know that's 36 times, flip it, 3 over 2. That's why that's on the top 20. Comes up a lot. Then I'm going to do a little canceling here. 18 times 2 is 36. The 2's then can cancel. And I get 18 times 3, 30, times 3 is 24, 54. There we go. That's what that one adds up to. Exactly 54. And if it doesn't hurt your brain a little bit that you're adding up an infinite number of numbers and it hits an exact number, then you're not thinking about it enough. It's kind of crazy that that works. Okay, so you've got a Schoology quiz that you can do to get ready for the big test tomorrow. Don't forget that growth is best written as a 1 plus, the increase. Like let's say you had a 1 plus 0.05, that means you're growing by 5%. 1 minus, 0.25, that means shrinking by 25%. That's the best way to do those. And without further ado, why don't you start that Schoology quiz, get it finished up tonight, check it because the answers are available after your first try, and make sure you're ready for the test tomorrow. That's all I got for you for today.